All right, in this lesson, we are going to be now focusing on hyperbolas. If you'll look at this, hyperbolas have very similar equations to ellipses, and we'll talk about how you can kind of tell the difference between the two in just a second here. Okay, so a hyperbola is the set of all points in the plane whose distance from two fixed points, which are called the foci, have a constant difference. And you can kind of read through the rest of this, and I'll teach you sort of some vocabulary that goes with this. Okay, so this is a hyperbola whose branches are left and right. You can see that there are two vertices. There's a vertex for each branch. Okay, and then the focuses or foci are both inside those each branch of the hyperbola. Okay, and then obviously there's a center. The axis or the line that connects the focus, just so you know, is always called the transverse axis. And I'll show you that on the next picture that's so that you can kind of see that. Okay. Um, there are considered to be two axes here. And I'm actually going to go past this and show you this. Okay. So that you can compare these. So on the left picture, it's a hyperbola that has left and right branches. Okay, so I just want you to notice this. The line that connects the foci, always, the line that connects the foci is always called the transverse axis. And the line that goes the opposite direction is always called the conjugate axis. What's a little bit confusing with hyperbolas is that the transverse axis does not need to be longer than the conjugate axis with hyperbolas, okay? With ellipses, the major axis was always longer. The one that connected the foci was always longer on ellipses. The one here with hyperbolas, the one that connects the foci, does not have to be longer, but it is called the transverse axis, just so you know, okay? The other thing you need to notice is that A is always the distance from the center to the vertex. Okay, A is always the distance from the center to the vertex. B, you're going to have this little imaginary box. This distance is B. Notice that in this particular picture, B is not, B is longer than A. Okay, so you need to sort of figure out that in hyperbolas, A does not have to be bigger than B, okay? A just has to be the one on the axis that connects the foci on the transverse axis, okay? Here are your handy dandy little formulas. I do want to point out too that when you have a negative sign in between, you cannot subtract in any order, okay? So I cannot switch these around and rewrite y squared over b squared minus a squared or x squared over a squared if it's a left-right hyperbola. I have to have them in this order with x listed first if it's a hyperbola. I also need you to know that, again, a does not mean that it's a bigger number. It just means that A moves along the x-axis because it's under the x in this case. B moves along the y-axis because it's underneath the y in this case. Okay? Does not mean that A has to be bigger or that it's going to be longer or wider one direction based on what number you see first. Okay? So I just want to point out that to you. All right. So this is kind of what it looks like. I think this will make more sense if we just do this. Okay? I can tell just by looking at this that this is going to create a hyperbola because of a couple things. First of all, I have x squareds and y, x's and y's that are both squared. Okay, in a parabola, I mean, you only have one variable that's squared. In an ellipse, both your x's and your y's are squared, but you have a plus sign in between. And in hyperbolas, x's and y's are both squared, but you have a minus sign in between. So I know for sure that this is going to be a hyperbola. Okay? In the standard form of hyperbolas, it is always solved for 1. So I'm going to divide everything by 36 so that I can get this into the right format. Excuse me. And then I will have x squared over 4 minus y squared over 9 equals 1. Okay, so the standard form, or I'm going to sort of graph this so that you can kind of see what happens. Okay, This means that your a squared, your a value, goes along your x-axis, okay? Because our standard formula goes like this: x squared over a squared minus y squared over b squared equals 1, okay? So this tells me right here that a squared is 4 and a is 2, okay? By the way, my center is 0, 0 here, um, because on this basic hyperbola, that's what's happening. Okay, so my center is 0, 0. My a value is 2. My a is underneath my x in this case. So I'm going to move along the x-axis 2 to the left and 2 to the right. Okay, I'm just going to make some dots there for right now, and you'll see why in a minute. Okay, then this tells me right here that b squared is 9, so that b is 3. Okay, that means I'm going to move from the center and I'm going to go up 3. Just going to make some dots for right now and down 3. Okay, now what I need to do is I need to think about making a box where I kind of box in, and I'm just going to draw all these right now. I'm going to box in everything that I see. I'm going to draw vertical lines there. I'm going to draw horizontal lines here. And do you see how your center is in, wow, what did I do? I went, sorry, my A value was 2, and I counted 3 over here. You guys are probably like, she's losing it. That's where my dot should go. Anyways, my little box, you can see, is boxed, or my center is boxed right smack dab in the middle of this box. Okay, so I'm going to erase that, and I am going to think about having that little imaginary box right there. Okay, so hopefully you can kind of picture how that's happening. What I'm going to do is I'm going to make that a little bit lighter with a different color marker, just so that that doesn't irritate us later, because I'm going to end up writing quite a bit here. Okay, so I am going to find myself a little bit of a different marker. I'm going to try to use a highlighter. Okay, and I'm going to box us in here. All right, so that's how it looked right there. Okay, then what you're going to do is you are going to think of drawing little imaginary lines that go through the corners of that box. Okay, so I'm going to draw imaginary lines that connect the corners. Let's see, can I draw this dotted? That connect the corners of that box. This isn't very straight, but you kind of get the gist. Okay, those are little imaginary lines that look like that. Okay, and now what I want to do is I want to think about drawing my branches of my hyperbola. And by the way, because I know x is listed first, I know my branches go left and right, okay? I'm going to think about the branches of my hyperbola hugging that green imaginary line. So if I were to graph it, my branches would hug that green imaginary line, hit the vertex, and go back and hug that green imaginary line. So my branches would look something like this. Okay? All right. Now, I know that this is a left-right hyperbola, so I know that my foci have to be somewhere inside of that, and I'm going to figure out where my foci are in just a second. Okay? Here's what I know. I know that this distance right here, which is A, is 2. Okay? I know that this distance right here, which is B, is 3. And then what I know, and this is what's tricky for some people to understand, is this distance, which is C, okay, just like on an ellipse, will be the same, because my foci are out here somewhere. So this distance and this distance are the same, okay? Both of those are C, just so that you can picture that. Okay, now I'm going to kind of clean this up a little bit so that we don't do this so much. Okay, I'm going to now solve for C. So what I know is that using the Pythagorean theorem, c squared will be a squared plus b squared. Okay, so c squared will be 9 plus 4, or c squared will be 13, or c will be the square root of 13. Okay, now if you want to be able to graph your foci accurately, you can figure out what the square root of 13 is. The square root of 13 is about 3.6, which means I need to go about 3.5 from the center. So this distance is the square root of 13, which means I can move that same distance, square root of 13, which happens to be about 3.6. So 1, 2, 3.6 would be put me right about there for my first foci. Okay, so that would be at negative root 13, 0. And then my other foci, of course, will be on the right side. So I'm going to erase this whole mess. And my other foci will be about the square root of 13 right at my center. So 1, 2, 3.6 right about here. This foci will be the square root of 13, 0. Okay? And that's all it asked me to do. All right, on to the next one. This time I'm giving you what your foci are, and I'm telling you the conjugate axis. Remember, the conjugate axis is the axis that does not have the foci on it. The transverse axis has a foci on it. The conjugate axis does not. All right, so I'm telling you that my foci are at 0, 4. I'm going to just label this foci at 0, 4 and 0, negative 4. Okay. My conjugate axis has a length of 2. Okay, now I already know that this is a hyperbola that has up-down branches because my focus has to be inside inside my 2 branches. Okay, so I know my branches have to go up and down instead of left and right. Okay, my conjugate axis, which does not connect the foci, so this axis in this case is the transverse axis. My y-axis is the transverse axis because it connects my foci. And my conjugate axis in this case would be my x-axis because it doesn't connect my foci. So my x-axis has a length of 2, which means that this is sort of the edge of my box right here. Okay, now here's the problem. I don't really know how tall, kind of, to make my box when I do this. I know the foci have to be inside this. So this is what I'm going to do. I am going to estimate where my little box should be. Okay, I'm going to estimate. I know my box has to go through here somehow, and it has to go through here somehow. Problem is, I don't really know how tall to make it. So I'm totally estimating. I'm just going to make my box right there. I'm, again, completely estimating it. Okay? If you think about making your little imaginary lines right here, I'm going to make this a little thinner so we can see this. If you think about making your imaginary lines that connect the corners of the, whoa, what just happened? That connect the corners of those boxes, I am going to move this line. And that didn't work very well. All right, we're going to undo this. I don't know what happened. It sort of snapped it for me and it didn't turn out very well. All right, I'm going to try this again. Sorry. I am going to do this. I'm going to make it a little bit. Okay, so I'm going to try to connect the corners of that box with sort of an imaginary line that goes like this. I'm not drawing it super straight, but you can kind of get the gist. Okay. What I know is that the branches of my hyperbola are going to go something like this, okay, because they're going to hug those dotted green lines, which are a little bit hard to see. But you can see that it goes something like that, and I am totally estimating this box. In fact, it's not even very symmetric, but again, I'm completely estimating it, okay? And here's why I'm estimating it. I want to think of this box in here. Here's what I know. I know that this distance right here, okay, which is B, because it is not along the axis that connects the foci. So my B is 1. This distance right here is A, which I don't know. Okay. This distance is C. And remember that this distance and this distance are the same. And I know that that distance is 4. Okay, I know that that distance is 4. So what I know is that C is 4. Okay, I am now going to figure out what A is by following the Pythagorean theorem. Okay, so A squared plus B squared equals C squared. So A squared plus 1 equals 16. So A squared equals 15, and A then is the square root of 15. So if you want to graph these more accurately, you can certainly go ahead and graph them more accurately. All I wanted you to do here is find an equation. But you can, if you want, figure out what the square root of 15 is, and then put this vertex at exactly the right spot. So that, but I just completely estimated, okay? And that's okay. I needed you to come up with a formula for this. Because my foci are along the y-axis, I know that I have to use this formula right here. Okay, my y has to come first because my foci are along the y-axis. All right, so I know that I'm going to have y squared over a squared. A squared is 15 minus x squared over b squared, which is 1. You really don't need that 1 down there, but if you want to put it, you can. Equals 1. Okay, in the book, they probably don't have this here, just so you know. Okay, they might. I don't know. All right, and I think that that will do that for this lesson. Oops.